Good day, everyone. We are presenting our final project for KKKM 6043 Advanced Instrumentations. The title of our project is IoT-Based Vertical Farming System. This project is presented by Dinesh Muthu and Ahmad Farhan under the supervision of Professor Hanif Saad. Presentation will cover the introduction, problem statement, objectives, scope of study, methodology, results, conclusion, and future recommendations. So, let me give a brief introduction about our project. So, what is vertical farming system? So, it is a modern agricultural method using vertically stacked layers to optimize the space and environmental control. So, what is IoT in farming? Traditional farming often lacks data-driven monitoring, which leads to inefficient irrigation, resource waste, and inconsistent crop health. So, IoT enables real-time monitoring, automation, and adaptive control based on plant needs. So, this project mainly focuses on developing a fully functional IoT-based vertical farming prototype, which uses ESP32 microcontroller to integrate sensors, actuators, and cloud connectivity. And it also implements remote monitoring and control via ThingSentral.my and Blynk mobile app. This particular figure, we can see how the entire vertical farming system actually looks like. So we have a water pump, pipelines, sensors such as ultrasonic water level sensor, temperature sensors, and light sensors, and so on. And in order to read these sensors, we have relay modules, control boxes, and for a proper ventilation, we do have an exhaust fan system and also remote switch actuator for the doors that we have in this particular. So this is a circuit diagram for our Arduino controller. So as we can see here, when we have a lot of sensors and controllers and modules and so on, we need to have a brain, which is the ESP32 controller, to act as a centralized module that can receive and transfer the signals from all the sensors and transmitters. So now let's look at the problem statement that we have derived for our project. So the first one is the inefficient resource use. So manual farming leads to water and energy wastage. Second is the lack of real-time monitoring, which leads to no data-driven insights for irrigation and environmental control. Third one is the limited automation, which most of the small-scale systems require constant manual intervention. And lastly, high cost of commercial solutions, which existing smart farming setups are very expensive for local and small-scale sellers and also business owners. So when we look at the objectives, we can actually derive them from the problem statement. First is to design to and build a low-cost IoT-based vertical farming system using a ESP controller. Second is to integrate multiple environmental sensors for comprehensive monitoring. Third is to develop an automated control-based sensor thresholds. Fourth is to implement dual platform remote access, which is the ThingCentral and also Blynk. And lastly, to validate system functionality through real-time monitoring and control. Study focuses on indoor vertical farming automation for leafy greens and herbs, including hardware assembly, sensor integration, Arduino programming, cloud connectivity, and system testing to ensure everything is in order and can function per its intent. Hardware system consists of an ESP32 controller connected to multiple sensors including soil moisture, temperature and humidity, light intensity, water level sensors, along with actuators such as LED lighting control using relay modules. This system was actually developed using low cost and easily available components to ensure affordability and accessibility. And the total cost that we spent for this entire project is around 399, which is consists of multiple sensors and also devices. Phase involved generating the Arduino code for sensor integration, data transmission, and automated control logic. The Blink platform was configured to enable cloud-based monitoring and mobile control of the farming system. ThinkCentral was implemented for cloud IoT data logging and real-time data dashboard visualization. Functional prototype was achieved, providing real-time monitoring of soil moisture, temperature, humidity, light intensity, and water level parameters. The system successfully performs automated irrigation based on soil moisture thresholds and automated fan and lighting control based on temperature and light conditions. Remote access and manual override are available through the Blynk mobile application, so the total system cost is approximately below 400, which is accurately RM399, making it affordable for small scale and educational applications with stable and reliable system performance. As we can see in this particular slide, the we are able to see the overview of the system and the trends that we have from our sensors. And this is our actual prototype. Project addresses major research gaps, including multi-sensor integration, cost barriers, single platform limitations, and lack of user control by providing dual platform access and manual override functions. In this slide, we have actually gathered all types of test results that we got from our prototype and listed down here. So each of them we had a target, a set point, and also the actual results we managed to measure. In conclusion, the project successfully designed, built, and tested an IoT-based vertical farming system using ESP32 controller, integrating multiple sensors, automated control, and dual platform remote monitoring in a cost-effective practical design. Future improvements include the integration of pH and nutrient sensors, solar powers, and predictive analysis using a historical data for proactive system control. This project demonstrates that IoT technology can significantly enhance a lot of parameters such as efficiency and also automations. So with that, we would like to thank and we can see the next video for functional tests of our project and sensors.